So our recent developments at Carnegie Mellon are our long-range iris system that we've built that can actually capture irises anywhere from 6 to 11 meters. So it's really important because you have a large capture volume at a long range, and so the user doesn't have to be at a particular X marks a spot. It's really key if you want to give the user a pleasant experience where you don't have to sort of be 10 to 12 inches away from the camera, move forward, move left, move right, out of focus, whatnot. So the system will actually automatically pan, tilt, capture the iris, and more importantly, it will capture close to an enrollment quality iris, and that's what sets our system apart from others. We can do long-range iris matching and enrollment, which is really key. It has the potential of actually saving lives in the field. Soldiers possibly using this, no longer have to use short distance devices. They can use our longer device, so they can authenticate or identify if all people within a 10-meter radius are, good guys, or if there's a potential bad guy among there. They don't have to drop their weapons, go up close within 5 to 10 inches to capture an iris. So that's a really key thing. If we can do something to save a life, make the user experience easier. I mean, the easier the biometric authentication is, the more friendlier it is, the less invasive the soldiers are, or whoever is deploying the system. And that's what's going to help biometrics in general get adopted. Sure. So another thrust that we're doing at Carnegie Mellon is what we call soft biometrics. And soft biometrics are just like biometrics are, except the features you get are softer. They cannot uniquely identify who you are, but they give a dimension of information. So for example, gender, age, all these give some information. So if I'm looking for somebody, say for example, a criminal event happened, right? And I would love if I can send the cameras a list of, okay, looking for white male, mid-20s, red sports jacket, mustache, no beard. And such a capability does not exist right now. But it would be awesome if we can actually give that, to give a possible candidate that the law enforcement can give to, somebody, a witness, to identify, okay, oh, that's the bad guy. Okay, catch him before he flees the scene. Where we're really using it is actually to make face recognition systems right now smarter. So most commercial systems, face matchers, are pattern matches. They'll find some pattern in the face and they'll match. And in their minds, they've done a good job. And when they give the top 20 or top 50 rank, you see the face, and sometimes as a human analyst looking at them, you're thinking, well, hold on, yeah, these look okay, but this first 5 are actually completely wrong. What does that mean? They're wrong because, oh, they may be the wrong gender, they may be the wrong age group. So the system thinks, oh, I've matched these features, but guess what? They're 20 years off. I mean, why am I matching? If I'm matching for a 20-year-old male, why am I getting a 50-year-old male as my possible candidate? Those are things that are, human would actually be the loop, would say, that's a clear mistake. So trying to add this human intelligence, artificial intelligence, into the facial matches will make current facial matches more robust. And that's what we're trying to do. At Carnegie Mellon, we have students, and students are always up to new catchy ideas and new ways to combine interdisciplinary research, right? I mean, how can you merge robotics with computer science, with computer engineering and biometrics? So in that direction, I bought them a couple of those AR drone quadricopters. They're like $300 or something, and they downloaded the SDK, programmed it, and now they're doing face detection and tracking, and autonomously having this helicopter basically follow you around and always looking in front of your face. Who are you, what are you doing, and so forth. It's a cool project, and it has applications. If you think military going out, sending a helicopter scout to just look what's inside of the building, is there an ambush waiting, or being able to just, maybe in the future be able to go capture an iris, right? I mean, it's up to your imagination of what the possibilities are. It's really cool to see if something like that can happen, because it truly can help benefit the soldiers and make an identity of potentially a bad guy before you're too close where you can be a threat and cause harm. That is the key thing. That's how biometrics can help. And also, more importantly, identify the good guys and let them go about the daily business, right? There's no need to change anything about people, normal people going on their lives. You only have to find, who are the bad guys and stop them from doing any harm. So we're also super excited about something we've developed at Carnegie Mellon, the ability to generate a 3D model of a face from a single 2D image. That's really cool, because if you think about trying to do and solve the pose problem and sort of the pose illumination expression or pi problem, pose is by far the hardest challenge, and that you cannot control. You may control the lighting, but you can't control the user is pose. So if you have a surveillance camera, people aren't always going to be looking at the camera. So how do you do matching off angle? And more importantly, how do you do biometric? Even if somebody is cooperating, you don't want complete cooperation. You don't want to have the user, okay, move left, move right. Oh, you know, you want the user experience again to be seamless and unobtrusive and immediate. Whether you're doing it for biometrics for access control, whether you're doing a robot that's just trying to interact with the user and figure out who the user is. You don't want the robot to have to follow you around, make sure you have a frontal face. So how do you solve the pose problem? And towards that, our 2D to 3D model generation provides a unique solution. And it's ultra fast, and we've actually compared it with actual 3D scanners to show that the 2D images we get back are rendered correctly. Now, application-wise, you know, this can solve the 2D to 3D, the 2D pose problem. It also has a lot of great applications, help possibly save lives and find missing children. You know, the Amber Alert program, a couple of years back, I'm not sure the exact time, but they're looking at possibly providing an Amber Alert capability where parents of missing children could provide the photograph. Well, the ability to actually generate a 3D model and look at the child from different views would help people identify the child, rather than just using a static 2D photo. So again, capability of using such technology to help and save lives, especially with children, I think that's a huge benefit, and you know, that's a big win for us. Another thing that I'm also involved in is exploring the biometric viability of a new technology, new and emerging technology, based on a radio frequency signal, something called the radio frequency interrogation signal, RFII, developed by Non-Invasive Medical Technologies. It's really cool because it's a device that monitors the vital signs, captures all the heart dynamics, heart movements, and we get a sort of a corresponding, the EKG correspondence, but we're not actually looking at the electrical signals, but the actual heart movement signals, biometric itself. What we're trying to do is trying to figure out if we can actually identify someone using that signal. So soldier would have this monitoring life signs, vital signs, making sure, you know, if something bad happens, you know, who needs medical attention first, which soldier is going to go into shock first. That's what the device can actually help. At the same time, can you authenticate who the person is so that, you know, we know that that is the actual person, or is it someone else put it in the suit? So that's a real game changer to be able to do biometric identification and also monitor vital signs simultaneously. That's one device, does both things. You don't need a different battery pack. You know, hardware consolidation, anything the soldiers carry, you don't want to carry two pieces. If you can do everything in one device, that's a win. So we're really excited about this opportunity and improving this new biometric, and I think it has a lot of potential to help the soldiers and save lives. PETA Biometric Lab is a new lab that we're forming at Carnegie Mellon, and it's joined with Autonomous ID technology that they've developed, and we will be essentially their research and development academic partner. It's really cool because imagine now that you have a biometric authentication capability that is literally an insole inside your shoe. You're walking around, it automatically authenticates who you are. There's no fingerprint. There's nothing specific that you've had to do to get authenticated. You didn't have to, you know, oh, I need to get through the door. Let me first stop at that fingerprint sensor, or let me make sure that iris scanner can capture me, and it'll take me a couple of seconds. Sensor is right there, automatically authenticates you. You've done nothing. There's nothing active you had to do other than just walk through the door. So applications, high security areas, authenticating the workforce, authenticating critical infrastructure. I think it's a great biometric, a new emerging technology that will solve a lot of the issues and also solve some of the privacy issues. The device will hold its own biometric template there. There is no database that it's searching against to. All it's going to do is authenticate that you are the person you're claiming to be. So we're very excited about this.